Hey, so I did a crazy thing last night. I already had configured my web servers and I had one worker node using a spot instance. But then this month, when I looked at my server bill, it was over $70, and I said, okay, I want to cut cost by half. So I then decided to move my main server, my main work node to a spot instance as well. And then, lo and behold, I found out that my whole applications on the server got destroyed. So I've been trying to fix it this morning, and I want to walk you through how to set up your own um, web servers using Kubernetes and deploying them on AWS, cost effectively. So today, what I found out is I'm going to switch to a reserved instance in order to save on my compute capacity. So when I come to a reserved instance, I could see that I can only make a reservation for a particular type of instance. So it's either I'm making a reservation for a T3 micro or T2 large or any instance type I'm going to choose. But this is not what I want. I want it to be also flexible. So in case I want to deploy more master nodes, then I would like it to also be covered with the discount. So actually, I have made some research, and the best way to do this is to go for a saving plan. So if you try and buy a saving plan for at least 1 year, then you can save up a lot on your web servers. So let's see how we can purchase a saving plan and then continue. Okay, so when we click on saving plans, then now we can say purchase a saving plan. So now we want to purchase a saving plan. Okay, what do we need? We need the saving plan type. So I want to save on compute capacity. So compute saving plan. All right. Now, I also want to select how long I want to be committed to this saving plan. Then I will say 1 year. All right. Then purchase commitment. So how much are we expecting to use hourly base? So upon research with AI, then the best amount will be $0.045 for me. So because I want to use sorry, what do we call it? I want to use T2 medium for my master node. So I'm going for 0.045 when you run it up. So payment option, then I want to say no upfront. So which means I'm going to be billed approximately $34 per month, which is way better than my compute cost, which was almost around $70 this month alone. So in total for the year, then I'll be paying AWS $406. All right. So now I'll add it to cart. And then I will submit order. Select it, and then I will submit the order. Order submitted successfully. So your order is being processed. It may take a while to charge your payment. If we need additional actions to complete your payment, we will email you instructions. Good. So now we leave the rest to AWS, and then now we can go ahead and deploy our service. So the best thing I have done was to use infrastructure as code. So, the very first time when I heard of infrastructure as code, it was like a rocket science. I was just seeing stars in the beginning, but it all makes sense when you take time to do it once, and then you can always repeat it and modify it and keep adjusting it however you wish. So in case you don't want to deploy your service manually, like I do not want, you can follow along with this script to set up your own web service using Terraform. So I like Terraform to set up my own web service because it's very easy to use, and also it is compatible with almost any cloud provider. So now let's say you want to follow how I have set up my own. You need a variables.tf file which should contain all these variables. So you can pause and then write this down, or you can just copy the code. So you will need an S3 bucket to store your file so you can share with your team. So you need to create an S3 bucket and give it a name. So I have already created my own S3 bucket that I have always been using. And then the next thing you need to do is also the region, and then the the machine image ID. You need that as well. And then we need the instance type. So my main server is going to use a T2 medium, which is good enough for me. And then you also give the key name so you can SSH into your web service. Now we also need to attach a security group to the web server, and then we need to tell it which AZ we want it to be in, the availability zone. Again, we also want to attach a volume size. I need a volume capacity of about 50 GB. And then the next thing I also did was I'm setting up a worker node instance type, which is going to be a T3 medium, because I need a T medium because this is where almost all my applications are going to run. So I need a higher capacity for it. And then it type is going to be a spot instance, because actually I don't really care so much that it will just, when there is no capacity available, AWS will take it back, and then I will still get my applications back running when capacities are available. So imagine if you want to scale your application to have multiple web servers. This is going to be cost effective for you. You'll be able to save a lot on money, so this will be good for you. But if you don't want it, you can also try and make your worker nodes use a T2 medium or T3 medium, which I don't know why you want to pay a lot for that right now. So let's save. And then the next thing we need to do is we need a setup.sh file. I already have a setup.sh file, which is for configuring Kubernetes on my master node. So setup.sh file is responsible for setting up all the configurations that you need. You just don't need to do anything. Everything will be done for you. So now you can also copy this code. You can just pause and copy the code, or you can just copy the code from my GitHub repo. I will have a link in the description down below. So you just have to copy the code now. Now we are setting up AWS CLI. we are updating, and then we are also preparing the kernels, and then now we are setting up the container D as well, and then we will restart the container D. Now we have to install the Kubernetes component, and then now we also need to set up the correct IP in the kubectl kubelet, and then also we will check if all these ports are free. If they are not free, then we have to kill it, and then make sure that before we initialize our Kubernetes on our master node, we are able to run it smoothly and not run into any errors. So that will be it. We will set up the network, and then we also install Helm on it. That will be good, because we need Helm to also install other packages as well. So now I'll save it and then leave it as it is. So the next file that you also need is you also need the Terraform config.tf file. So this is where you are going to provision all the web servers you need. We give the IAM role for the EC2 instance, and then we attach the administrative policy to the role. We also ensure that the server is going to have instance profile, and then now we have to create the main instance. So this is my main instance for my master node. And then the next thing is we add a life cycle. So whenever we say Terraform destroy, we don't want to destroy it to prevent accidentally destroyed. So the next thing, we move on to the worker node. We need to provision the worker node, also give it the tag, and also give it the instance profile as well. And then we also add the policy to it. That is good. Then when you are done with that, the next file you need is the providers.tf file. So you need the providers.tf file, which you are going to tell it which cloud platform you are going to use. So I'm going to use AWS, so use GCP when you see it fit. And then the next thing you need is the Terraform config.tf file. This is where we configure the S3 bucket for the backend state for our Terraform. Okay, that is good. So I'll save all these files. Now I have my Terraform configured on my local machine because I don't want it to be exposed to the internet. So this is being backed up in my iCloud, so I have total control over my own server configuration. I don't want to expose any sensitive information. But you can also use GitHub Actions for running your infrastructure as well, but I prefer to run it this way for now. So now I will just say Terraform, because I've already initialized. If you just added all these files, the first command you need to run is Terraform init. Then need to say it is initializing. Okay, and then you say Terraform. Let's check if everything is formatted well. Terraform fmt. That is good. Now the next thing we need, Terraform validate. Let us validate it. Terraform validate. Say success. Now let us see which resources it is going to create for us. So Terraform apply. Terraform apply. Okay, it says cancelled, but let's run it again. What was the last command we ran? Validate. So let's run Terraform plan before apply. Terraform plan, so we see the resources before. We always have to run Terraform plan before you run the apply. So Terraform plan, then we see we are going to add 5 resources, and then 0 to change and 0 to destroy. This is very good because sometimes you might make a mistake and then you will be deleting a server. So imagine you are deleting your database server, which is going to be very dangerous for you. So I did it. I know how it feels. So don't, a wise man learns from the mistakes of others. So try and be wise. Then the next thing we will do is to say Terraform apply. Then give it a moment. Say yes. Then now it is creating all the resources for us. So let us give it a moment and then ensure that we get all the resources created successfully. So now it has been 5 resources have been added successfully. So let us go to our AWS account and have a look. So now go to EC2 instance and then let us see the resources that are being created. Nice. So now we have 2 instances that is being created for us. This is good. So we created one for the master node and one for the worker node. So this is the best and smart way to always manage your infrastructure, because you can always replicate and then do this at scale instead of trying to launch every instance and do all the configurations, SSH into the instance, and then run all the commands that you could do. It's going to be tedious, trust me. So I would recommend you to take the time and then try to set your web servers as infrastructure as code. And it can also serve for a disaster recovery purposes. So this is very good. Nice. So let us wait whilst it's initializing. It's still checking. So let us wait. Nice one. So now that we are waiting, the next thing I would like to do is to SSH into our web server and check. So connect and then go to SSH client, copy this, go to your terminal, and then ensure that you have your key perm here, because you need your key perm to be allowed to SSH into your web server. So I'll clear my screen again. I will make this a bit bigger. Hope you can see now. So now I will just run my command here and then say yes. Good. I have SSH into my web server. Now let us check ls no files on my server yet, and then I will check kubeadm version to see if Kubernetes is installed. Confirm Kubernetes is installed correctly. kubectl version, confirm we have Kubernetes component on it, and then I will let us check if kubelet is running. So system ctl status and then we will say kubelets, not kubelets, kubelet. Good job. Now we can see kubelet is running as well. So now, yes, everything is running. So now we can see run k get ports. You can get the ports, all ports. Now we have all ports running successfully. So now you can move on and then deploy your application. So now the next step I am going to show you is to have a feel on how we deploy production grade application onto your web servers using Kubernetes. So I'll clear the screen again. And then, but before we do that, let us see how many nodes we have. So k get nodes. And then you see we only have one master node, and then that is ready. So now we need to join our worker node. So in order to join the worker node, we need to run this command kube adm -h. Let's see what we have. So we have join, and then we have token. So we need a token. So kube adm, clear the screen, sudo kube adm token -h. So yes, so now we can create a token, and then let us run it's create. So I'll clear the screen again so you can see. Clear the screen and then run the last command we did, kube adm token create. Then let's run -h and see what we can do. So now kube adm token creates. Then we have all these flags that we can provide, but we need this one, print join command, so that we can join. So you can read it here. Instead of printing only the token, print the full kube adm join flag needed to join the cluster using the token. So if you want to join another worker node into your master node cluster, you just need to run this command and then get the token. So I will run this command. So clear the screen again. Let's get the last command we ran, and then I'll paste this one here, and then I'll run it again. So now we have this command that we need to run on the worker node in order for it to join the master node. So I will save this somewhere, and then we will also SSH into the worker node. So again, save it somewhere. I'll save mine somewhere, open Notepad, and then put it there. Good job. So now exit your master node server, clear your screen, minimize your terminal, and then also let's go back to AWS console. So AWS console, and then go to instances. Now find the worker node, and then connect also SSH client, copy the example, and then go back to your terminal, and then paste it here. So run it and then say yes. Now we have successfully SSH into our worker node. So let us check if we have Kubernetes installed on our worker node. So kube adm version, before we even run that token we created. Now we have kube adm on it. So kube ctl version, and then let us check if kubelet is running. Clear the screen, system ctl status, and then kubelet. Okay, so kubelet is running on our master node, so that is good. That is good. System ctl. So kubelet is running on our master node. So at least let us check kubelet version. No, I spelled kubelet wrong again. So let's see. It's system oh my god, system ctl status, and then you say kubelets. So it is should be running. Yes, we have kubelets here. So this is a node agent. That is good. Stop it. And then we could see we have a problem with kubelet on my worker node. So it shouldn't be so. It shouldn't be so. It shouldn't be so. Let's restart it. System ctl restart kubelet. Now we need to run it with sudo privileges. So sudo systemctl restart kubelet, and then check the status again. So let us also check if container D is running successfully on our worker node. So systemctl status container, it is running successfully, and see if it's enabled. Yes, it is enabled. So we have a problem with the kubelet. We need to ensure kubelet is running on our worker node as well before we can even move on. Okay, so after looking into it, I think we just need to join the master node so that it will have all the certificates and the config in it for the kubelet to also run. So let us try and run the token we generated. So copy that token and then go to your worker node and paste it there. So it couldn't join because of user privileges. So you have to add sudo and then paste the command. And then now, boom, we could join. Now, boom, we could join we could join the master, we can join the cluster. So that is good for now. So now let us try and see if we can verify if kubelet is also running on the worker node. So kubectl, now system ctl status, and then we say kubelet service, kubelet service. Yes, now we can see kubelet service is running. Good job. Now we can exit our worker node. Exits, clear the screen, SSH into the master node again, and then clear the screen, and then now run get nodes. Let's see how many nodes we have. Now we have 2 nodes, so one master node and 1 worker node. So now that we have set up our infrastructure successfully, the next thing we need to do is to take a break and grab a coffee. And then in the next step, I'm going to show you how I deploy web applications at scale, because I already have my portfolio and I already have some web application services running on my server previously, and then I unfortunately took it down. So now I'm bringing it back again, and then you can also follow similar steps and then run your web applications. So clear the screen, and then I will take a break now. So now we are back, and we are going to continue our server configuration. So if you haven't watched from beginning, kindly do so to watch from beginning so you can come up to speed. So now the next thing I'm thinking about is we can have our web server. Let's SSH into the web server. We can have a web server without monitoring. It's always very important to monitor your web server. So the best way for us to monitor our web server and web servers using Kubernetes is to use Prometheus plus Grafana. So that is the next step we are going to do. So I will minimize. Let's first of all get ports -a. Nice one. So now we need to add a monitoring service to our web server. Before, let us check if we have Helm installed. So Helm version. Good job. We have Helm also installed on our master machine. So clear the screen. Now I'll minimize it, and then I will go to my configurations. So it's kubeadm setup. Yes. So I've gone through already, and I have all my files that I used to configure my web server stored in here in kubeadm setup. So I'm going to run you through, and then you can also again pause and copy the codes, or again you can also follow the link in the description to also get access to the same code, and then you can just copy and paste from there. So in order for us to install, first of all, the first thing we need is a local storage path for our system. So I'm going to create the local storage path by copying this command. So basically say paste this command here. So keeps it here, create a namespace. So now we are creating the namespace called local path storage. I'll create that one, and then the next thing is to install the storage class. So let us install the storage class from Rancher. So clear the screen, and then we will paste this command again. Good job. So clear the screen. Now let us check on it. So get ns, get all the namespace. Now we can see we have storage class namespace. So get ports -n local storage class. Boom. Now we can see we have a local storage provisioner working. So get sc. Good job. Now we have a local storage that we can always reference. Good job. Now verify if it's up. Yes, we already did. And then we also need to override the default class. So let's override the default class. So override the default class on it by running this code. Boom. So now we have overrode the default class. Okay, get AC. Nice one. So it says it's a default. It's set to default now. Nice one. All right. So now that we have created that, we need to install Prometheus and Grafana using Helm. So now we are going to install Prometheus and Grafana using Helm. So now copy this command. We need to create a namespace called monitoring. This is where we are going to have all our monitoring ports. And now inside we copy this command. We need to add the Prometheus repo to our system. So run this command. Now we can add, now we have added the Prometheus repo. Update the repo. Okay, so now we've updated the repo. So clear the screen and let's check if it's there. Clear the screen. So Helm repo list. We can see we have it here. So now we are going to install this repo using Helm. So I will copy this command. But before that, we need to make sure we have this file, monitoring values.yaml file. So monitoring values vim monitoring values.yaml file. What do we need inside this file? We need all the configuration that our Prometheus is going to use to configure with Helm. So where do we get this file from? So I have, if you come into Prometheus plus Grafana, you could see I have the monitoring values file here. I will just copy the code and then I'll paste it inside here. Nice. So now we are setting up our Grafana also with this value, so you can always give the username whatever you want, and then you can also give the admin password and all those things. So yeah, but always remember not to share your password with anybody, because now that you've seen mine, I'm going to change these values after I have finished with this setup. So now when you save the file, so it's just Vim, and then you just have to save the file. So clear the screen. Now we've saved the file. Okay, now that we've saved the file, let us go back to the bash file. So we need to install it. So copy this command and then run this code. Good. So now we are installing it. Give it a moment whilst it installs. Good job. So now we've deployed it successfully. So now I'll clear the screen and then I will check if it has installed successfully. So let us check if it has installed successfully by running this command. So helm list -a. So now yes, we can see we have installed it successfully. Clear the screen. Okay, get ports -a. Now we can see monitoring with Grafana is running perfectly and smoothly. Sweet, that's what we needed. Clear the screen and then let us go back to our system again. So we go back to our system, and then the next thing we need to do is we need to run a certificate issuer. But before we run the certificate issuer, there is a couple of things we need to do. So we need to run a set manager. We need a set manager for our system, so that we can use SSL certificate. Okay, so I will create this file. So I will say set cluster issuer. So I'll go to my server again, and then vi, and then we create this file. So now let us copy and paste this code here. So now we are going to make the certificate issuer for our system. So now save the file. Good job. Now that we've saved the file, also before we run that command, we need the engineer's controller on our system. So yes, so it's many configuration that we need to do, and in a future videos I'm going to try and run these commands in a GitOps so that it will be much more efficient. But for tutorial purposes, I just want to show you how it is done manually, and then you can see what we could do in the future. So now, in order for us to first of all, let us check if we have engineer's controller on our system, so which is going to do the load balancing for us. So get ingress controller. Ingress. Okay, so I can't tap to have autocomplete. So now let's go back to the browser again before we continue. Go back to the browser and then look for kubernetes.io. Look for cheat sheet. Everybody like cheat sheet. Quick references, and then we just say we need autocomplete. Boom. You copy this one, go on your system, and then run it. Oh, I did not copy it well, so ensure you copy it well. Clear the screen and run it. Now we have installed it successfully. Need to put power on my machine before it dies out on me. So clear the screen now, and then let us try what we were doing again. So get ingress. We do not have any ingress -a. We do not have any ingress controller on our system. So first of all, we need ingress. So what do we need to do? Okay, so in order to set up the engineer's ingress, let us create it by running this command. So we'll run this command to create an ingress resource into the ingress namespace. Boom. So get ns. You will see now we have ingress namespace. So get ports and then -n and then ingress. So now we are waiting for it to be successful. So now when we check it again, now we can see our ingress is running successfully. Good job. Get ports -a. Boom, everything is running as it's supposed to run. All right, now we need to patch our ingress so that it can run on the master node. So we will just use this patch command to run it. So clear the screen. So and you just have to ensure that your Kubernetes your system name is just master, because I have mine as a master. I have the label as a master on my node, my master node. So I will just run this command, and then we can see we've patched our system. So that is good. Now we also need to patch it in order for it to use node pod. So let us patch it so we can use node pod. So because we are not using what do you call it? We are not using load balancer. So first of all, let's check on it. So get ingress -a. Ingress class. Get ingress class. We have engineers ingress. Nice. So let's check the service. Get svc-n ingress. Boom. So now we see the service is running a load balancer. We don't need that because we want to keep our cost very marginal. So now I'll clear the screen and then we will patch it like this. So let's go back to the code. Let's go back to the code and then copy this patch command to use node pod instead of the ingress, instead of the load balancer. So now I'll paste this command and then I'll run it. So once we have run this command, let us get it again. Okay, run the previous command that we ran before. Now we can see our type is notepad. Good job. Good job. So that's it for setting ingress controller on our Kubernetes cluster. So I'll clear the screen and then we will move on. Now that we have applied the patch, let us try and then set the replica for our ingress resource to 2, so we can have one on the master node and one on the worker node. So get ingress get pods -n -ingress. So you will see, let's check on which node it is running. wide, we see it's running on the master node, so we need one to run on the worker node. So we'll go back to the code and then copy this command, and then we'll come here and say paste it, and then now we've scaled it. So let us run the command we ran before. Boom. So now we have one ingress resource running on the worker node and the one also running on the master node. So that is sweet. Boom. So now everything is running perfectly for us. So clear the screen and then we will move on. Now that we have done all that, we need to go back to the Grafana. Let me close all this one so we have focus on one file. So we need to go back to installing Grafana ingress. So we need to set up this Grafana ingress for our system. So now create Grafana ingress, and then you say view, and then create this file, copy this code and put it here. So the host name that I'm using on my domain is grafana.jobwithmate.com. So I'm just configuring it so we can use TLS SSL for my application. So you can just also configure the same for your application by just putting your host name here, and then you are done. Replace it here and replace it here also. So you are done. Now save it, and then moment of truth. So we need to apply. So now back to the shell file for the Grafana. So we created this. We need to apply this Grafana file. So kubectl apply. So now what was the resource we were creating? Ingress. So get ingress -a. So now we have one for Grafana. This is good. So now it is working fine for us. It has been deployed successfully, and then we need to get the certificate monitoring. Let us confirm. We don't have it yet. We don't have it yet. We don't have it yet. Good. So let's see if we have certificate issuer. Get issuer set. Get set. It should be certificate issuer, but I have an issuer here, so we need to run this file in order to provide certificate issuer for our system. So set manager issuer. Set manager issuer. We already run this. So it's called cluster issuer. So K gets cluster issuer. Cluster issuer. Cluster issuer. K gets cluster issuer. We don't have that yet. ls set issuer. So cat, have we already run that file? So K apply -f and then this file, resource mapping, let's prod no match for kind issuer. So first of all, we need to ensure we have installed the CRDS. Okay, so we need to ensure that we have monitoring metrics on our system. Before we forgot that step, so we have a monitoring metrics. So change host name issuer, deploy a metric server. Yes, so now we deploy a metric server by running this command. So install the metric server, clear the screen, K get ports -a. It is creating metric server. Let's give it some time whilst it is still creating. K gets nodes. Ensure all our nodes are ready so we don't have any problem. Okay, we have a problem with the metric server, so okay, let's run again. No, so clear the screen. K get ports again, and then let's describe. K describe, let's find out what is wrong. K describe pod -n cube system -n is cube system. Describe. Describe readiness probe. So we have this readiness probe. So let us first of all patch it. Let us first of all patch our metric server. So metric server is needed to get all the logs for our web applications or deployments. So run this patch and then K get ports. Still not ready yet. I'll check it again. Still not ready yet, so probably something is wrong. Boom. So just needed time. Now that we've patched it, it just needed time, and then our metric server, it's running successfully. So metric server, or is it metric server? A metric server is running successfully, so that's good. Now I believe we can move on to the next phase. Now that we've applied those, let us see if we can run our set issuer again. Set issuer. So certificate issuer, and then we are using the engineer's class name. So we already have it, ls set issuer. So cluster issuer. So k apply -f and then this file. Cut this file. So in order for us to run that, we need to ensure that our set manager is being running before, which we forgot. So let us see if we could update this sh file. So I'll make it well. So certificate set issuer. So I will move this file into the folder, and then I will also cluster issuer file, set manager. Remove this one also here. Yes, so we need to first run this command. Yes, so that is good. Now let us see if we can, let's check the namespace. Okay, get ns set manager. Now we have set manager. Let's check the ports. K get ports -n set manager. Good job. Now we have it running. So let's see if we can apply our set issuer. So k apply -f, apply this file. Boom. Now we've got our set issuer running. So good job. So k get cluster issuer. Yes. Then now we can see our let's encrypt resources is ready to be used. All right. So that seems like a lot. It is a lot to configure. So now that we've done all those configuration, let us apply our Grafana ingress. ls Grafana ingress. So what is the resource going to be? Ingress. So k get ingress. We do not have any resource here, so k apply -f Grafana ingress. Boom. We already have that running. -a. Oh my god. Let's first of all get ingress for all namespaces. Now we could see Grafana ingress has been running here. Nice one. So one more thing we need to do before we progress. Is we need to ensure that now that we have configured our Grafana using our domain. Let us go back to AWS console. So when you're on the AWS console, now go to EC2 again, and then go to instances. Now select the master node and then copy the master node public IP. So go back to Route 53. This is where we are going to configure all the DNS. So I've already done that. So I'll select the domain, job with main, and then I'm going to point my domain A record to my EC2 instance. So I'll click this one and then I'll edit it. So now we can save the file, and then now we are done. So it should be possible to see our application soon on the World Wide Web. So now, in order for us to see our deployment on the World Wide Web, there's a few more steps that we need to actually do. So one of the first steps, let us first of all open our configurations. So which one was it? It was this one, yes. So the last couple of steps that we need to do, we've already scaled our system, and then now we need to connect the host network to the proper DNS. So we just need to run this command to attach our network to the host DNS policy. So I'll copy this command, and then I'll go back to our terminal, and then I'll first of all SSH back into my web server, clear the screen, and then let us run this command. Good. So once that is done, then we need to check out the deployment rollout status if our ingress controller has been deployed successfully. So open the terminal again, and then I'll paste this. Good job. So remember, you can always go to the description, follow the link there, and then also get access to the same files that I'm copying from, so it will be easier for you. Now, previously we changed the service port to a node port, but then since we have attached the network policy to the DNS, we need to just use a cluster IP instead of the node port. So I will run this command to change it back to node port. Run it. Good. Everything is working successfully. And then let us test and see. You always need to verify for moment of truth. So if port 80 and 443 for SSL is working on our system. So now we have those ports ready and listening on our system. So clear the screen. All right, it seems to be done. So now for a moment of truth, let us go to the browser and see if we can open the web application. So go to the browser, and then it was grafana.jobwithme.com. So with your domain. So boom. Now we could see we could log in into our system. I believe I've already logged in, so I can just log out, and then I will be able to put my credentials and log in again. So I will be back again when I have put in my credential to log in. So now we've been able to successfully log in with our credentials. So you can check your dashboard over here. You can check almost everything that you want to see here. I just want to see something with resources. So I see all my resources. Okay, so I just want to see compute resources. Nice one. So congratulations. Now you've been able to set up your own web server using Kubernetes, and then also set up monitoring on it. And in the next phases, I'm going to show you how I use Git actions to deploy my web application. So I'll show you how I deploy my backend APIs, and then I also show you one of the products that I've been working on, how I deploy it to the clusters as well. So stay tuned as we move on to the next phase. So, and do not forget to subscribe as well. So, and click on the notification icon. So when I upload the next video, you will get the notification, and then you will also be able to jump on and see how far you can bring your projects.